paper question all about frictional forces and acceleration. Have a look at the question, and then when you're ready to see the explanation, press play. Okay, we've got two identical boxes. They've got different masses, so that might be important, and they're sliding with the same initial speed. So the important thing here is that they are sliding, and therefore we're looking at dynamic friction. They both come to rest under the influence of the frictional force, and we're asked two questions. How do the frictional force and the acceleration of these boxes with different mass compare? Important thing, as we've said here, it's a horizontal surface, and so therefore we can apply the equation that you're given in the data booklet, which is the friction force is the coefficient of friction times the reaction force. Now, in the case of a horizontal surface, R is equal to the weight of the object. We're assuming that we're in equilibrium in the vertical directions, and so therefore our frictional force is equal to mu times m times g, and this of course is the coefficient of dynamic friction because we're moving. This should help you rule out a couple of options. The frictional force depends on the mass, and so therefore we can confidently say that the friction force are different because they have different masses. We're then asked about the acceleration. We can use the fact that the only force acting on the system is the frictional force, and that is going to cause an acceleration. It's going to produce the resultant force, and that's equal to mass times acceleration. We can substitute our value for the frictional force, where we've got ma is equal to mu mg, and notice there we've got m's in both cases, which are going to cancel, and we find that the acceleration is equal to mu times g. And you can see that that is independent of the mass, and so therefore they are going to have the same acceleration, and that's why our answer to this question is B.